Alright, so we all love detecting objects with YOLO. It's pretty rad. Now, when it comes to custom objects, things are a little more difficult. We need to create a dataset, annotate it, retrain the model, possibly quantize it to run on an accelerator. Let's see what we can do about this. Okay, so here we are running a YOLO. We're detecting an office chair and a couple of bottles. What if we wanted to detect something else? For example, let me see, brown paper bag sounds good. Here it is. That was easy. That's exactly what we are talking about. Okay, so this model is based on YOLO World, which combines both vision processing that you can see here at the bottom and text processing at the top to define your classes. In a nutshell, this model works by first processing video through the vision backbone that we can see here at left, and at the same time processes the class names defined by the user through the clip model from OpenAI. And that gives rise to some embeddings. Those are later combined with the video to give rise to the detection boxes for those classes. So with clip, you can define pretty much any class name you want, and then you use those embeddings to reparameterize YOLO World so that the classes will become embedded into the model. And at runtime, you can just remove the whole clip processing to make YOLO World faster. There is just a small problem with that when you want to quantize a reparameterized YOLO World, which is that the quantization is going to take some time each time you change the class names. All right, so we address this in two ways. In the first one, we are just going to leave the class names open and just input them to a model that has been quantized for everything except for that class processing. In the second variant, we go even further, which is that we can already pre-process to some extent all of the text-related stuff up to the last possible point where it's going to merge with the vision processing. Okay, let's try it out. All right, so I have a little scene here. You can see I have a bunch of balls. Let's see if we can recognize them. So let's first try maybe a red ball, and here it is. Let's keep going. How about now a yellow ball? There it is. You can see that little purple box is for yellow ball. How about now some blue balls? Blue ball, here we are. This is working. Amazing. I like it. Now here is the kicker. With clip, you can not only define classes by text, but also by image. So here is another little setup with a clean background, and we are now going to try to define this object by image. So I click this live select button here, and I'm just going to draw a box around that fork. And here we go. Now I have a detector for that fork. Now hopefully it should generalize to more forks. So I have a few more that have slightly different shapes. Here is another one. Looks good. It should hopefully be relatively robust to pose and orientation as well. Let me see if I have more forks here. Here is one with just 3 teeth. Looks good too. Maybe a black fork. Okay, no problem. So I have now my fork detector. It took less than a second to train it. Let me see now if I can bring back some other classes. For example, my balls. The forks are still good here in this orientation. Let me try to find my balls and see if we can add them to the mix. And here they are. Looking good. Maybe the red ball is a little weak. So for that, you can adjust your thresholds on a class-by-class basis in this model. So here, let me reduce it a little bit. Okay, it's good now. Now, don't get me wrong, this is still a little bit experimental. It doesn't work so well for all classes. Sometimes you get a lot of false alarms if you reduce your threshold so much. But nevertheless, it looks very promising. So try it out and let us know what you think.